Hi everyone. This video is going to be running through a demonstration of Dijkstra's algorithm for finding the shortest path between two vertices on a weighted graph. It's a fairly complicated algorithm, so I thought I'd make this video so you have something to refer back to when revising it. The algorithm has three key steps: the setup, filling the grid, and then backtracking. We're going to use this weighted graph here as our example. So the first section is the setup. You first need to identify your starting vertex and simply write it on the page. You write the remaining vertices in a row above the starting vertex. I find it useful to separate it by a line. Write the edge weighting of each edge connected to the starting vertex beneath that vertex in the row. So a lot of words. All that really means is look at whichever edges A has connected to remaining vertices. So I can see that A connects to B with a weighting of 3. A connects to C with a weighting of 5. You put an X under every vertex that has no connection to your starting vertex. So that would be D, E, F, G for us. We then put a box around the smallest number in that row. In the case that there are two smallest values, you box just one of them. And that's the setup complete. Step 2 is filling the grid. I'm going to copy this here so I don't have to rewrite it. Beautiful. Step 2, filling the grid. In a new row, you write the vertex which was most recently boxed in it. So we can see that vertex B has the box number in that column. So I write my new row starting with vertex B. Step 2 is you copy all boxed numbers from the previous row into your new row. In this case, it's only 3. Then, for each empty spot in the new row, we add the weighting to the vertex of that column to the most recently boxed number. So take a look. I can see that B has a weighting of 1 in its connection with C. So what I would do is I would take 1 and I would add it to the most recently boxed number. That gives me a value of 4. If there is no connection from the currently boxed vertex to that new vertex, you copy whatever is above. So we'll see that happening in a moment's time. If there is an X above that spot, you write the new number in that spot. If the new number is greater than or equal to the number above that spot, copy the number above. In our case here, if the new number is less than the number above that spot, write the new number in that spot. So that last point is what we observe here. We can see that B to C has a weighting of 1. And if I were to do 1 plus the most recently boxed number, that gives us a value of 4. So that means I'd put a 4 in this box, as 4 is less than the number above it. Brilliant. Let's have a look at B to D. I can see B to D has an edge weighting of 6. I do 6 plus 3 to obtain 9. The spot above here has a cross in it. This means a new connection is being formed, and we put the new number in. Let's have a look at B to E. B to E has an edge weighting of 1. So I do 1 plus 3 gives me 4. B to F. There are no connections from B to F, so you just copy what's above. Same goes for B to G. Beautiful. As before, we now box the smallest unboxed number in that row. You box only one of them if there are duplicates. So we can see here, the number in column C and column E are both 4, sharing the role of the smallest number. The great thing about this algorithm is it does not matter which one you pick, you will get a valid solution either way. So I'm going to box this vertex. Here's the fun bit. We repeat those steps 1 to 4, until the end vertex is boxed. So already, you can see this is a rather tedious procedure, but it does give you the correct answer. So, let's run it through. We just boxed a vertex or a number in column E. So, E is my new row. We copy all boxed numbers down, only the 3 and the 4 so far. Then, for each connection coming from E, we add the weighting to the most recently boxed number, which in this case was 4. Let's take a look. E to C. There's no direct connection from E to C, and when this occurs, you copy the previous number. So look at D. E to D has a weighting of 4. So if I take 4, the weighting from E to D, and I add the most recently boxed number of 4, I get 8. 8 is less than 9, so we write the new number in there. E to F. We can see that E to F has a value of 1. So I'm going to take 1, add it to 4 and get 5. This makes a new connection, as the spot above the 5 is a cross. So we write 5 in. E to G. We can see E to G has a weighting of 7. So I do 7 plus the previously boxed number, most recently boxed number, and that gives me a value of 11. As again, we've completed the row, so we now box the smallest number. Nice. We can see that box number belongs to column C, so C is our new row. As before, we copy down all boxed numbers. And repeat. C to D has a weighting of 2. So let's take a quick look. If I add the most recently boxed number to 2, I get 6. 6 is less than 8, so I write 6. Have a look at F. C to F, there's no connection or no direct connection, so I copy the previous number down. C to G, there's no previous connection or no direct connection, so I copy the previous number down. Again, I box the smallest unboxed number. That belongs to column F, so F is my new row. As before, we copy all unboxed or all boxed numbers into the new row. F to D. F to D has a connection of 5, or a weighting of 5. I do 5 plus the most recently unboxed number. I get 10. However, 10 is greater than 6, so we just write 6 again. F to G. F to G has a length of, or a weighting of 3. So I add 3 to the most previously boxed number. That gets me 8 in total, and 8 is less than 11. So I put 8 in that spot. Box the smallest number, look at what column that belongs to, and start the new row. We are now nearing the end of the algorithm. Is there any connection from D to G? There is no connection, so we copy the previous number and box the remaining number. This is now step 2, filling the grid, completed. I'm going to copy that to use for the next section. The next step is backtracking. Backtracking is where we actually determine the path that we need to take in order to get back to G. So I'm going to change pen color for this. We start at the box number in the column of your end vertex. That's the 8 we just boxed. We draw an arrow from this box vertically upward until the last instance of the boxed number. So we can see that the last time I see the number 8 before going higher is this second last row. So I'll put an arrow from the 8 that's boxed, up to that last instance of 8. We then draw an arrow from this box horizontally, left or right, it could be either, until the row vertex, so F, matches the column vertex. In this case, it's really quite simple. We just move and draw an arrow one spot to the left, where the row and column now match. Beautiful. We repeat steps 2 to 3 until we reach the top row. So, step 2 was draw an arrow from this box vertically until the last instance of that box number. I can see the number is 5, so I draw my arrow up until I see the last 5, which is that one there. I then move horizontally across until I'm in the same row as I am column. Or same column as I am row. And then move up until I see the last instance of that number. And move across till I'm in the matching column. And then up again until the last instance of that number. I'm now at my top row. We draw a line, I draw an arrow horizontally to the starting vertex. Nice. A horizontal arrow indicates movement along an edge. Look at the start and ends of each arrow to determine the path. I can see that we start at A and we move on to B. That's that horizontal arrow to B. We then see the next horizontal arrow takes us from column B to column E. The next horizontal arrow takes us from column E to column F. And the last horizontal arrow takes us from column F to column G. Therefore, A, B, E, F, G is the shortest path between A and G. The value of the most recently boxed number is the weight of the path. That is the total weight of the path. So we can see that's 8. So we have a total weight of 8. And there we go. That is Dijkstra's algorithm for finding the shortest weighted path from one vertex to another.